Okay, so this is the worksheet that is assigned to you, and we're going to work on some of these rules. So I'm going to pick some random problems from here, and we're going to be talking about the rules that apply for rule of exponents. Okay, so starting on the first one, the first one is 2n to the third times 3n. Okay, so the first thing you have to look at is the numbers, right? You have your numbers, you have your variables, and you have your exponents, okay? So now the 2 and the 3, these are our coefficients. All it means is the numbers in front of the letters. You can multiply those together. Okay, and we're going to get, well, let's see, 2 times 3 is 6. And then now, when you multiply the n to the third times n, don't forget there's an invisible 1. So n to the third is going to get multiplied times n to the first. Okay, now there's a rule. When you have the same variable, right, when you have the same base, the powers, you can add them. Right, you can add the 3 and the 1. You can just go ahead and add them. So the 6 stays the same, but now the new exponent is 3 plus 1, and that's 4. Okay, so there's your answer for number 1. Sorry, let me move this a little bit. All right, so that's number 1. Let me jump down to a question like number 5. Number 5 is a good one. So number 5 is, inside the parentheses, we have 3x squared raised to the 0 power times 3x to the third. All right. So here you're going to be applying the 0 rule. Basically, whenever you have something like this, because it's to the 0 power, the whole thing becomes just 1. It just disappears completely. The rule for anything to the 0 power is going to be 1. Okay? So it doesn't matter what was in here. It literally didn't matter what was in here. Because it was to the 0 power, it automatically becomes a 1. Okay? So it's basically 1 times 3x to the third. Well, 1 times 3x to the third will stay the same, 3x to the third. So there's your answer for number 5. Okay. All right, and let's jump over to number 11. Number 11, we have 3xy to the third, and then that's being raised to the third power, times xy to the third squared. Okay, so now this problem is going to apply a couple of rules. So we'll start with the first one. Anytime you have a power outside like this, that power is going to apply to the 3, to the x, and to the y. Okay, so basically we're going to multiply the power 3 times all the powers of the ones inside. Well, if you look at the 3, it doesn't have a power, so you have to put the number 1. The x doesn't have a power, so you can assume it has a power 1. Okay, so these two have a power 1, and all of the powers inside are going to get multiplied times the 3. Okay, that's called power to a power rule. So you're going to multiply 3 times all the powers. Okay, so let's see what this is going to become. This is going to become 3 to the 1 times 3 is 3. X to the 1 times 3, so 1 times 3, that's going to be 3. And then y to the third power, so then 3 times 3 is 9. Okay. And then we're going to repeat that same exact rule for the next one. Okay. The x, I don't see a power on there, so I'm going to put the number 1 there. Now, again, these powers are being raised to another power, well, you got to multiply your powers together. Okay? So let's go ahead and multiply our powers together. That becomes x to the 1 times 2, that's 2. 3 times 2, that's 6. Okay? Alright, so now that I've distributed the powers, now I can focus on this. 3 to the 3rd power, that means, let's put it up here. 3 times 3 times 3. Well, 3 times 3 is 9. 9 times 3, that's going to be 27. Alright, so now, once I'm done with that x to the 3rd, I'm sorry, the 3 to the 3rd, I'm going to go ahead and just cross it out. That way I can kind of keep my work organized as to what I've done and what I haven't done. And alright, now I'm going to bring down the x to the 3rd, I'm going to bring down the x squared. So I'm pretty much bringing down the x's, okay? I'm bringing down the x's. So let me go ahead and cross them out. X to the 3rd, already brought it down. X squared, already brought it down. Now I'm going to bring down the y to the 9th times y to the 6th, right? Bringing this down. Okay, so that's gone, that's gone. Alright, so now everything has been rewritten and everything's nice next to each other. So let's see what this is going to become once I use my exponent rules. So the 27 has no other number to multiply again, so that will stay 27. X to the 3rd times x squared, well, we have the same variable. You're going to add the powers, okay? So 3 plus 2, that gives me x to the 5th power, okay? And again, if you want to do the same exact thing, once you're done with them, cross them out, cross it out, cross it out. Then the y, same variable, add the powers. 9 plus 6 is 15. Okay, and we're done with both of those. So we've already taken care of everything. So ask yourself, can I combine anything else? Can I combine the x and y's? Well, do I have the same variable? No, I do not. They're very different variables, so that's how you know you're done. Okay. All right, so that was number 11. All right. Let's see. Now, you guys can always email me questions. If in case you guys are stuck, you can always reach out and ask me any questions. All right, so you guys can always pause the video and rewind it if you want to hear an explanation again. So let me go ahead and erase the board. Okay, so the next problem I'm going to be working on is, let's see, let's do another one like the one we just did. I'm going to do number 8. Okay, let me do number 8. So number 8, that is parenthesis x, y to the 3rd times 2y x squared, and the whole thing's being squared. Okay, so let's talk about some options that you could have. An option you can do is you can go ahead and combine the variables that are the same inside and then apply the power, or you can multiply the power times everything and then combine everything. My preference is to always simplify inside and then apply the power. Okay, that's just my preference. In my opinion, that's been the best practice. It pretty helps. It helps a lot to simplify first. Simplify first inside. Okay, that's some best practice right there. So, well, let's see. I see that I have no number in front of the x, and I see a number in front of this y. So basically, there is a invisible 1 here. So 1 times 2, that's still going to be 2. Now remember, we're still working inside this parenthesis. So whatever I simplify inside, that's going to still be raised to the 2nd power. Alright, so I just multiplied 1 times 2. That gives me the 2. Now I have x times x squared. well, if you want to go ahead and write it out, let's write it out. X times x squared. All right, and then we have y to the third times y. So y to the third times y. Now we have the variables next to each other, so that makes my life a little easier. It's going to be 2x times x squared is going to be x to the third times y to the third times y. Remember, there is a 1 here, right? There is a 1 there. 1 plus 2, that's where I got the 3 from. 3 plus 1, that becomes y to the fourth. And again, the power is still the same on the outside, right? The power is still 2. So now that 2 is going to get distributed, right? Power to a power, the rule is to multiply. So the biggest mistake people do is that they multiply the 2 times the 4, 3 times the 2, and that's it. But they always forget to distribute to the number. The number is also being squared. So that has a power of 1. So I have to multiply the power on the outside times the power here on the inside. Okay, so well, I don't need this anymore. I'm squaring the whole thing. So 2 to the, what's the new power on it? 1 times 2 is 2. 3 times 2 is 6. And then y to the fourth, 4 times 2 is 8. So now here's just what I'm given. I can simplify 2 squared. 2 squared means 2 times 2. Right, there's 2 2's, so that's 4. X to the 6th, y to the 8th. Alright, and there's my answer for number 8. Okay. Alright, and I'm going to do one of the fraction ones. I will do, let's see. You know what, I'll do 2 of the fraction ones. I will do number 15. And I will also do, let's do number 19. Number 19 looks a little crazy. Alright, so let's go ahead and start with number 15. So number 15 we have in parentheses 3yx cubed. And then this is being divided by 3y x to the 0 times x to the third y to the third. Okay. Alright, so the first thing that I am going to do here to start us off is to apply the power of 3 inside everything in the parenthesis on top. Okay. So the 3 has a power of 1, the y has a power of 1, and the x has a power of 3. But since all 3 of them are being raised to the third power, I gotta multiply my powers together. Okay, so that's a power to a power rule. So 3 times the power 1, 3 times power 1, 3 times power 3. Alright, so it's going to stay 3 to the 1 times 3 is 3. Y to the 1 times 3, so y to the third. And x to the 3 times 3 is 9. And then after that, let's go ahead and move over to my denominator. Alright, 3 times no other number, so that's pretty much going to stay 3. Y and y to the third. So because we have the same variable, we're going to add the powers. 1 plus 3 gives me a y to the fourth. So I'm going to cross them out since I've already combined them. And then last but not least, let's go ahead and combine x's. So x to the 0 times x to the third. Same base, add the powers. So 0 plus 3, that's still 3. Okay. Now this is where it gets interesting. Okay. Now I'm going to use the subtraction rule. Now I like to use the subtraction rule in a way where that makes sense, because if you follow the textbook style of applying the subtraction rule, you're going to end up with a lot of negative powers, and sometimes that could be a little tricky for students. So the way I am going to use the subtraction rule is basically I'm going to ask you a question of where do you, whoops, I'm going to run out of room. Where do you have more? Okay, where do you have more? So ask yourself, where do you have more threes, top or bottom? Well, I have more threes on top because I have 3 threes, and on the bottom I only have 1 3. So I'm going to use the subtraction this way. 3 minus 1 is 2. Now, where does it belong? Well, where do you have more? You have more on top. So that's where my answer is going to be. My answer is going to be on top because that's where I have more. 3 minus 1 gives me 2. And that becomes your new power. Here, let's try that again. Where do you have more y's, top or bottom? Bottom. I have 4 y's on the bottom. So I know my answer is going to have the y on the bottom. Now let's subtract. 4 minus 3 is 1. So watch that again. Where do you have more y's? Well, compare the powers on the y's. On the bottom you have more. That's so I know the answer is going to have a y on the bottom. So 4 minus 3 gives me 1. That's why I have the 1 here. Okay, so that takes care of the 3's and the y's. Now, where do I have more x's? Top or bottom? I have more x's on top, so I'm going to put the x on top because I know that's where the answer is going to be. So 9 minus 3 is 6. Okay, so, and that's it. There's your answer. Alright, remember, don't forget to pause the video if you have any questions. You can always rewind something if you want to hear the explanation. Alright, so let's go ahead and erase this. Now, I said I was also going to do number 19. So let's take a look at number 19. Number 19, we have u squared v to the third times u to the negative 2 v to the 0 divided by 2u to the third v squared times 2u to the third, and the whole thing is being raised to the 4th power. Okay. Alright, so this question has a couple approaches. You can either start on top or start on the bottom. It doesn't really matter. But best practice is to start on the bottom where it looks the most complicated. And so let's go ahead and start on the inside and multiply my numbers together. So what is 2 times 2? Right? So in my parentheses, 2 times 2 is 4. Now, I have 2 u's here, right? So u to the third and u to the third. Right, so because we have the same variable, we're going to add the powers. So this one has a power 3, this one has a power 3. So 3 plus 3 gives me a u to the 6th power. Okay, so that takes care of the 2's and that takes care of the u's. Now, v doesn't have anyone else to multiply against, so that's going to stay v squared. Okay, so that's also being raised to the 4th power. Okay, so now that I have this power and the inside is simplified, I'm going to apply the exponent of 4, and I'm going to multiply it times all the other powers. Power to a power, you multiply. Okay, and even the 4 is going to get multiplied. It doesn't have an exponent, but there's an invisible 1 there, so you have to keep that in mind as you start to distribute that 4. So 4 times 1 gives me 4 to the 4th power. Then u to the 6 times 4, that's 24. And then v to the 4 times 2 is 8. Okay? Now, the top, let's take a look at the top for a moment. Is there anything there I can combine or simplify? Well, let's take a look. I have 2 u's. So as I have the 2 u's, I can go ahead and add my powers on top. So now if you're sitting at home and you have more than one writing utensil, like a pen, pencil, or different colored pens, this could help those of you who are visual learners, right? Here are your u's. Add the powers. What's 2 plus negative 2? Well, let's take a look. U squared and u to the negative 2. If you're going to add a 2 and a negative 2, that's going to become u to the 0. Okay? So that takes care of the u's there. Now let's go ahead and look at the v's. V to the third times v to the 0. So let's go ahead and write that over here. V to the third times v to the 0. Same base, so add the powers. 3 plus 0 is still 3. So our v doesn't change much, but I do realize that I have a u to the 0, and anything to the 0 power is 1. So that pretty much is gone. 1 times v to the third, right? 1 times v to the third, that's still going to be v to the third. Oops, let me write this a little different. All right, so in the denominator, I have 4 to the 4th, u to the 24th, and v to the 8th. All right, so ask yourself, where do you have more v's? Because I see that we have a v on the top and v on the bottom. Well, I know that I have more v's on the bottom, so that's going to change the way I'm going to subtract, okay? Because whenever you have variables on top and bottom, you got to make sure you subtract, okay? So let's see how this is going to look like for us, okay? So we're only focusing on the v's because everything else is pretty much canceled out and simplified. So the 4 to the 4th, that's still there. The u to the 24th, that's still there. Now we got to deal with the v's. Where do you have more v's? Well, I have more on the bottom, so I know my answer is going to have a v in the bottom. So now I can subtract. Because I know I have more on the bottom, you're going to do 8 minus 3. And that gives you 5. Now, if you end up with a negative exponent, that means that you subtracted incorrectly. Or if you have negative exponents in top and bottom, and then you try using the subtraction rule, then you got to try something else. And we'll get to that in a moment. So let's take a look at, so we said that the v's are going to simplify, have v to the 5th on the bottom. Because I don't have anything on top, I need a placeholder on top. So I am going to put a 1 on top. So that becomes my placeholder. Okay. So that's my answer for number 19. Now here's a little side note. So what if you had something like this? What if you had x to the minus 2 divided by x to the minus 5? Something like that. Well, this is a very good question. Okay, what do you do when you do this? Well, let's try. Let's try the same thing we did a moment ago. Where do you have more? Well, this is kind of a weird situation. Does that question even help you? Where do you have more? Well, what's bigger, a negative 2 or a negative 5? Well, technically a negative 2 is bigger. So if you try doing this, you end up with negative 2 minus a negative 5. Let's see. Negative 2 minus a minus 5. Remember, double negative, that becomes a positive. So what's negative 2 plus 5? 3. Right? So I'm going to end up with 3 as a power, but I don't know where it goes. Now remember, I did ask myself, where do I have more? Right? What's bigger, a negative 2 or a negative 5? Well, a negative 2 is bigger. So because the negative 2 is bigger, the answer will go on top. So that's going to become x to the 3rd. And I no longer have an x on the bottom because I did the subtraction rule. So then the answer ends up being on top, so my answer is being divided by 1. So x to the third divided by 1. Well, divided by 1 doesn't really change anything. So that means my answer is x to the third. Okay guys, I hope you enjoyed this quick mini lesson. If you have any questions, please make sure you reach out to me at otorres27@cps.edu. Thank you.